Hi devs! In this video, I'll be continuing the discussion on technical leadership, and this time I'll be focusing on technical excellence. So as we discussed before, your primary goal as a tech lead is to deliver an excellent product on time. So to achieve the excellent product part, the TL needs to lead their team into producing and building technical excellence. But what do we mean by technical excellence? So think about that for a moment. In my mind, technical excellence means delivering well-written code that's easy to maintain, easy to improve, and easy to enhance. It also means creating a product that is stable and scalable. So while a TL needs to lead the team to produce technical excellence, that doesn't necessarily mean that the TL is the most technically capable person on the team. So I've seen a lot of managers who have a team that needs a new TL just look over the team and they'll just pick the person with the highest technical skills. However, I don't think that's always the best way to choose a TL. I've seen many TLs succeed even when they are not the most technically capable person on the team. In fact, I've appointed several TLs who are not the most technically capable person on the team. But the reason I chose them, it had more to do with other leadership qualities that a TL will need. Now, please don't misunderstand me. A good TL does need good technical skills, but they don't need to be the expert in everything. So given that, what skills does the TL need? All right, the technical skills that I think a TL needs most are a sense of what needs to be done and how to design and put together a system that can accomplish that. However, detailed design skill isn't needed so much as the ability to analyze proposals and ensure that a good one is chosen. It's also important that the TL has an understanding of the biggest technical needs and challenges that the project will face, and then how to prioritize and drive the technical issues. These issues will include things such as maintainability, development velocity, performance, scalability. A good TL will ensure that the team is general enough that it can be improved over time and targeted for multiple uses, but they'll also know how to avoid overgeneralization so that the project can actually be built and delivered. A successful TL will know what makes good code, they'll understand trade-offs between maintainability and velocity, and they'll be able to establish a culture of excellence. So for the remainder of this video, I'll be speaking about the technical excellence that the team needs to have. Now, it's up to the TL to make sure that these skills exist or are learned by the team and spread as broadly across the team members as possible. Okay, so I said that technical excellence includes delivering well-written code. What do I mean by that? So I've always had this strange notion that code should just look good, that it should be aesthetically pleasing. In fact, I once had an argument with a coworker about whether software development was an art or a science. I felt that there's art in the craft. Now, obviously, computer software is very precise and it's a technical undertaking, but I think that well-written code also has some aspect of beauty. You know, I was later formally introduced to this concept of beautiful code when I read Martin Fowler's book, Refactoring, shortly after it was published. That's where I learned about code smells, how to spot code smells, and how to eliminate them. These ideas made a huge difference in how I approach writing code. Now, I don't want to take time to delve into code smells and refactoring in this video, but I would encourage you to explore the concepts. Keep in mind that code may be read 10 times more often than it is written. In fact, you may be the one reading your own code many months or even years later. I suggest you work to make sure that that experience is as simple as possible. When code is well written, it's easy to maintain. Maintaining code involves things like fixing bugs, removing technical debt, enhancing it with new features, and improving automated testing. On the other side of the coin, if the code is poorly written or poorly designed, then when you fix a bug or add a feature, you'll likely introduce more bugs, and often in areas of the product that are unrelated to where you are working. If you find yourself in this situation where the number of critical bugs seems to be always growing instead of shrinking, then you'll be unlikely to deliver a quality product. In that case, you should look at the code quality. Look to see if the code is broken into small independent modules and functions, see if it's easy to understand, decide if people can work on it independently without stepping on each other's toes, and is it well tested. So a good TL will help the team write good code from the beginning so that they don't fall into these traps. Technical excellence also includes shipping a stable product. This means that the product has relatively few bugs, and when bugs are reported, that they can be fixed in a timely manner. Now, the best way to produce a stable product is to have a solid automated testing culture. Usually automated tests come in the form of unit tests that aid in development, along with functional or integration tests that are performed when the code is submitted to the repository or before it's deployed to production. Martin Fowler's book on refactoring also introduced me to unit tests. Now, when I first saw about and read about unit tests, I was confused. Why would anyone want to write an automated test that simply called a function with no input? What good is that? But once I understood unit tests, and especially test-driven development, it completely changed the way I approach software. I started writing software a long time ago, and I've seen many revolutions in programming languages and in development practices. I lived through the transition to object-oriented programming, to interpreted languages, delivering software online, cloud computing, and many others. I maintain, though, that the thing that made the biggest difference in how I write software was unit testing. Why? Because a good suite of unit tests gives me so much confidence in the quality of my code. It lets me make sweeping changes to the code with confidence. Test-driven development is amazing in how it helps me think through the problem I'm solving and make sure that I am writing code that works as expected. I strongly urge you to study and adopt all of these practices. Well, what about scalability? Yes, a technically excellent product must also scale to meet demand. If you are fortunate, there will be a lot of demand. There are many approaches to scalability, but they generally involve spreading the work out across many computers. Cloud services nowadays provide a lot of different technologies that help with scalability. For example, a database can be easily spread across multiple computers in the cloud. Functions can be hosted in small cloud services that automatically grow and shrink with demand. Queues and publish-subscribe systems can coordinate the work across multiple computers. These are all technologies that a TL should be familiar with, and then the ones that the project uses, those need to be understood in depth by the team. So that's quite a bit that a TL and a team need to achieve on the technical side. Remember, though, that most senior engineers are able to go out and do research and learn a lot of this stuff on their own. But also remember that the knowledge and the skills for all of these do not need to reside in one person. In fact, if you spread out the knowledge and responsibility across the team, you'll most likely have happier engineers. And if you make sure that 2 or more team members are skilled in each of them, you'll have more fault tolerance on the team, and you'll allow people to take vacations or to change teams. Also, make use of any training resources you can find, online or otherwise, and use consultants, either those within the company or outside the company, that might help you get up to speed. So there's one final approach to technical excellence that I think needs to be discussed, and that is the code review. I have seen a contentious code review culture tear a team apart, and I've seen a sloppy code review culture result in buggy or unstable products. But on the positive side, and even more important than those negatives, I have found that the code review is an amazing mentoring tool. In a code review, you can encourage best practices, you can point out places where the code is not easy to understand or where it may be hard to maintain. In fact, I think people learn best how to write good code by having other people read their code and critique it. So the wise use of a code review can have a very large positive impact on the team's overall technical excellence. Just make sure to keep the code reviews cordial and polite. Do not let them get contentious. One technique I've found that tends to keep code reviews positive is to place the burden for the final code on the developer and not on the reviewer. That is, don't view the reviewer as a gatekeeper whose job it is to make sure that no bad code makes it into the repository. Instead, the reviewer should be viewed as a mentor who's there to gently point out ways the code could possibly be improved, to serve as a backup check to make sure that nothing glaring was forgotten. I like to tell my teams that if you have 20 engineers writing code to solve a problem, you'll have 30 different ways of writing it, and 15 of them will be excellent. So it really doesn't matter which of those excellent versions gets submitted. Let the person who wrote the code make the final decision on what to submit. Okay, those are some brief thoughts on technical excellence. It's obviously a broad topic and much more could be said on each of the points I've made here. But for now, I hope this has been beneficial. Thank you.